Assalamualaikum and a very good morning to everybody. So today we will go to the second presentation entitled Quality Control. Okay, this is the continuity from previous presentation. I have explained the importance of calibration to set up a test system to obtain the required readings. However, how to determine that the calibration is giving the correct results? It is by using the quality control. And apart from ensuring that the calibration is in the correct condition, it is also to ensure that all the components in the test systems are also correct. So we can refer to the this list. It is to ensure that the calibration, chemical reagent or solution, analyzer and water are in the correct condition. However, a QC, quality control or QC, is not suitable to verify the specimen or samples and test method or test principles. Yeah. These two components need to verify via quality assurance or total quality management activity. And as additional, QC also can be used to verify the operator and lab environment. If the operator is performing the test in appropriate way, the QC result may be wrong or violated. For environment, if the temperature is not suitable for the test, usually we need the temperature room, it can also affect the QC result. So why quality control? Why we need to perform QC before or during analyzing the patient specimen? It is because we want to make sure that all the patient results are correct or accurate. It is also for the patient safety. For example, if the patient have end-stage renal failure and need to be on dialysis, however, the lab produce the normal renal profile instead of the abnormal. This will lead the doctor of not performing the dialysis on the patient and could endanger the patient's life. So below are the function of the QC. Yeah. First, to monitor the accuracy and precision of the complete analytical process, to detect immediate errors that occur due to test system failure, adverse environmental condition, and operator performance, and to monitor over time the accuracy and precision of test performance that may be influenced by changes in test systems performance and environmental conditions and variance in operator performance. So please take note that QC does not monitor the pre-analytical and post-analytical process of the test, which we will go into the next section. And so that area also could affect the accuracy of the test result. Therefore, total quality management is used to monitor the error in pre-analytical and post-analytical area. So these are the difference between QC and calibration. So QC, it is a substance similar to patient's sample. The concentration consists of mean and SD based on a group of data from one lab or many laboratories. While calibration, it is a substance with specific concentration, and the concentration is based on the CRM or SRM and traceable to test reference method. So the function of QC, first to checking the instrument's calibration and most of the analytical component, to detect analytical error and problem stability, while the function of calibration is to setting the analyzer to the test requirement and produce calibration curve that can be compared and estimate the concentration in the sample. And more, the function of QC It is to measure the accuracy and precision, to prevent incorrect result, and help in troubleshooting. So QC should be performed after analyzing calibration and before or during analyzing patient sample, while calibration should be performed before analyzing the QC and patient sample. If not, then how we want to measure the sample, right? Okay, there are two types of QC, which is internal quality control and external quality assurance. Okay, for internal quality control, the definition, it is a set of procedures undertaken by laboratory staff for the continuous monitoring of operations and the results of measurements in order to decide whether the results are reliable enough to be released, and it ensures the constancy of the results day to day. While external quality assurance, and other name of it is external quality assessment or proficiency testing scheme. The definition is system designed to objectively assess the quality of results obtained by laboratories by means of an external agency. So from now on, I will go through the internal quality control. So the production of internal quality control or IQC could be as in the list, either dependent control, in-house control, or independent control, and also we call as third-party control. So for the dependent control, means that the QC material is produced by the same company that supply the reagent and analyzer. In-house control mean that the laboratory produce its own QC material. And for independent control means that the IQC material is produced by different company that supply the reagent and analyzer. This is under laboratory diagnostic accreditation such as MS-ISO 15189. This kind of QC material is necessary where possible. So these are the properties of the IQC material. So we will go through one by one. First, the IQC should have the same metric as patient sample, such as the metric is blood, plasma, or serum. So, example here, if the patient sample is serum, then the IQC should be serum. If the patient sample that we analyze is urine, then the IQC also should be urine material. So this can be accomplished using pulling actual samples of human serum, pulling animal serum, or using the artificial protein based solution that has some physical characteristic as human serum. Second, it can be in lyophilized or liquid. So the IQC material could be in lyophilized or in liquid. Lyophilized mean freeze dry form. Yeah. So this is the difference between the lyophilized QC and then the liquid QC. For lyophilized QC, the material stability is much longer, up to 3 years, while the liquid QC, the material stability is much shorter, either 2 years or less than that. However, for the lyophilized QC, it need proper preparation during the reconstitute process, while for the liquid QC, it is ready to use and no preparation needed. So There is a volume issue during the preparation, so or during reconstitution, that we need to use the tool that could deliver volume with high accuracy. If the volume being used is not correct, that it can affect the concentration of the material in it. In this case, is the analyte of interest. Usually, we use volumetric glass pipette with A grade. And please remember that the reconstitution process, meaning that the process of restoring something dried to its original state by adding water or solution to it. Third, the IQC can contain the analyte either in single or multiple. So IQC material usually contain analyte of interest, analyte that we want to analyze, and the analyte could be one, two, or more in the QC material. QC that the have one analyte described as containing single analyte, and the QC that have two or more analytes we describe as contain multiple analyte. Some QC is made single analyte due to the stability issue. Maybe if we mix with another analyte, then the analyte can easily deteriorate. Okay, a bit difficult to pronounce it. And usually laboratory will use multiple analyte of QC due to easy of use, because for one QC we can analyze many analytes or many tests, and it can save time, energy, and cost, and less error of it. Number 4, QC also usually in the aliquoted form. So most IQC are bottled in aliquoted form. Aliquoted means the material is stored in small volume from a larger quantity. Usually the QC material we can see in 1 ml, 5, 10, or maximum 5 mils. It is because once the upper IQC material is open, the material will be and taken out from the store medium. It is subject to evaporation and thus cause easily changes in concentration. When the concentration change, then the IQC cannot perform its function to monitor the precision and accuracy of the test. And also, after the IQC being open, the material will be aliquoted into smaller volume. The purpose is to maintain the integrity of the analyte concentration. Okay, this is the diagram of aliquoting the IQC material. So it is the storage of IQC material is different with the chemical. Usually the chemical material can be stored in bulk of 1 liter or 2.5 liter, while the IQC material usually we will find 5 ml, 200 microliter, or the maximum is 15 ml. When let's say if we want to use one set of this IQC material, each IQC material need to be aliquoted to smaller volume, which is enough for analyzing before use, so that for one QC bottle we can use for several times. Of this example, for this example, when we want to use the QC, we just take one aliquoted QC and we analyze into the system. And after we use this aliquoted, either we can discard it, or maybe we can use several times according to the manufacturer recommended. So IQC have a non-concentration, which consists of mean and range. The concentration values of analyte of interest is obtained after being analyzed several times, minimum 20 times, in one or more laboratory. So mean will become the target value of the IQC, and range is the acceptable value of the IQC. It will have the minimum and maximum value. Yeah, minimum and maximum limit. So this is the example of the IQC material and the insert that come with it. So in the insert, it has been assayed and it already have the value of mean, yeah, and the range, and it contain the analyte or test that can be used inside the QC material, yeah. And for this QC, it got the two level of QC, that is level 1 and level 2, and both level have the mean and range for each of the analyte of interest or the test that we want to use. Okay. Also, the IQC have one or multiple level of concentration. So most IQC material have two level of concentration, either normal or abnormal, or low and high. And some IQC material have three levels of concentration, either normal, abnormal, or very abnormal, or low, medium, and high. And seldom IQC material that have one level of concentration. So the use of two or three levels of IQC concentration will ensure that the laboratory that they produce the accurate result at the clinically important concentration. And please take note that the concentration should cover medical significant level or clinically important range of the analyte concentration. So this is the example of two levels of IQC, which is the normal level and abnormal level, and the analyte that contained in it is renal profile, liver function test, FSL, and etc. And this is the example of three levels of IQC, which is normal level, abnormal level, and very abnormal level. And maybe the analyte could be renal profile, liver function test, fasting lipid, serum lipid, and etc. 7. The stability and volume should enough for certain period of time. Okay, because the IQC is used for every day and it is used for the daily monitoring. And please be note, in 1 year of operation, there will be changes of operator, reagent lot, calibration, environment, and other. So, if we frequently change IQC lot, we cannot determine whether the variation of IQC results are due to either previous factor or the IQC factor. Okay, therefore, the stability and volume should cover for maybe 1 month, 6 months, 1 year, or maximum 3 years, depend on the analyte stability. The purpose, every batch of IQC have its own mean and range plus, which we use to monitor the precision and accuracy in long-term run. So change of IQC batch or lot, the mean and range value will change. Thus, it is difficult to monitor in long-term run. And for in-house IQC or IQC that need to self-develop concentration, whenever a new batch is going to be used, laboratory need to re-establish the concentration the mean and range. This will take minimum of 20 days, which is statistically significant. Therefore, it will cost a lot of work to do, time and operator needed. So, how do manufacturers develop the QC, or even you to develop the in-house QC? First of all, we need to pull the sample until sufficient amount of usage, maybe 6 months or 1 to 3 years. So, and for this process, we need to consider the analyte of interest. Example, if the IQC material for RP and LFT should contain sodium, potassium, urea, creatinine, AFP, ALT, total protein, yeah, albumin and bilirubin. And we need to consider the level of IQC. Example, for two levels of IQC, RP should have two pool of serum that contain normal and abnormal renal profile. So some additives such as bovine can be used to add in the IQC material to achieve target level. So this diagram show how to pull the human serum, meaning that we take the serum from many patients or many subjects, and we just pull it in one container. And this is the pool human serum of 3 liter and 1 liter. And then afterwards, we need to run the sample every day for at least 20 days, but preferably 1 month or more. So we analyze the pool sample every day. We analyze the analyte of interest. Example, the IQC for RP, we need to analyze sodium, potassium, urea and creatinine. And the control should be assayed over an extended period to ensure that it is subjected to changes in laboratory environment that may occur with different operators or at different times of the day. And remember to record the data obtained. And then from the data, we need to calculate the data to get the mean and ST of it. So theoretically, repeating the same sample will produce same result. However, it does not happen, and there will always be variation in results produced of the same sample. So with a correctly operating system, repeat testing on the same control sample should produce a Gaussian distribution. Most of the data will concentrate at one point, and just a small portion will spread far from this point. This is approximately 68% of value should fall between plus minus 1 ST range and be evenly distributed on either side of the mean. 95% of value should lie between plus minus 2 ST and 99% between plus minus 3 SD. The remaining 0.3% of the data theoretically spread out to infinity. So please remember that two levels of IQC will have two sets of data. Same with the three levels of IQC, meaning that two levels of IQC will have two means and two ST. Okay. So how to calculate the mean and ST? This is the formula for mean, and this is the formula for ST. So in QC, the mean will become the true value or the target value. Yeah. And the ST will become the limit of acceptability of control value. Usually we will use the plus minus 2st. So after we got the QC material, or we develop the QC material, how to use the or how to perform the IQC. So we need to run the IQC. So when is the suitable time to analyze the QC? Usually before or during analyzing the samples, or it can be beginning of each shift after an instrument is serviced. And also we need to run the IQC when there is changes in reagents lot, after calibration, and when the patient results seems inappropriate. The QC result also must be within acceptable limit before releasing patient result. If the QC result outside the acceptable limit, then we cannot release the patient result. And frequency of analyzing the QC for CLIA guideline, it is 8-hour to 24-hour interval. And other method, it depends on the total number of specimen. If the lab receive less than 50 specimen per day, then we just need to run one QC level per day. If the lab receive 50 to 100 specimens per day, then it need to run 2 QC levels for each day. And if the lab receive more than 100 specimens per day, meaning that the lab need to run 2 QC levels 2 times per day. But usually we perform this number 2 and number 3, although the specimen is less than 50 for our confidence, right? So how to interpret the QC result of data? Yeah? First, by quick checking, which I have mentioned below. If the QC data is fall within the acceptable limit, then the QC result is okay, and we can release the patient result. Second, we use the Levi-Jennings chart. And third, we use the Westgard multi-rule. So now I will go to the Levi-Jennings chart. It is a graph that the QC data is plotted on to give a visual indication whether a lab test is working well or not. So the x-axis means that represent frequency or time of analyzing the QC sample, while the y-axis represent the SD of the QC data. So the y-axis consists of mean and SD of 1, 2, and 3, and it also can be stated as actual value of concentration that synchronized with the mean. This is the actual value of concentration, which is synchronized with the mean 1SD, 2SD, and 3SD, and also minus 1SD, 2SD, and 3SD, minus 3SD. It also has two sections. First is the positive SD section or plus SD section, and also have the negative SD section. The positive SD section meaning that the QC value is more than the mean, while the negative SD section meaning that the QC value is less than the mean. So the purpose of Levi-Jennings is to ensure that the data is within acceptable range, that is plus minus 2SD. It is to detect small but significant error. So how to plot the daily QC data on Levi Jennings chart? In this example, the mean is 250 and the 1SD equal to 8 unit. I call it the unit as unit, okay? 8 unit. So example, for the QC on day 6, this is the QC on day 6. The data, the result is 258. Therefore, the SD for QC6 is 258. You minus with the mean value and then divide with the SD value. So you got the SD1. So you plot it in here. Okay. Okay, we go to the second example. Let's say we go to the QC data, QC day 11. Yeah, the results here is 240 unit. So therefore, when we want to plot here, if the value here is plus minus 2 SD, mean plus minus 1, 2 and 3 SD. So therefore, the SD for QC that day 11, 240, the value of the QC, you minus with the mean and divide with the SD of 8. So you got the minus 1.25 SD. See, this is 1 SD. So this is the minus 2.25 SD. So question, what is the SD for QC day 14? I'm sure that maybe you can give the answer without calculating it. But if you have enough time, you may calculate what is the SD for maybe the other day, like day 16 or day 17. The target LJ, meaning that the good LJ chart that we always dream of. Yeah, usually the QC data is near to the mean, and the distribution of the QC is quite symmetry. The number of the QC data on the positive side is same or more or less same with the QC data on the negative side of the section. However, there will be error that can detect on the Levi Jennings chart, yeah, after we plot for some time. It consists of systematic error and random error. For systematic error, there is trend error, bias, and shift error. Systematic error means that change in mean of control value or remain constant or predictable magnitude. So for trend error, it is gradual increased magnitude of the QC on the same side of the section, either positive side or negative side, and may eventually will go out from the limit. So for C and E represent the trend error. Okay, C and E represent the trend error. Bias, it is consistently on the same side of the section, not symmetry, and it may be near to the mean on the plus or minus, it may be near to the mean of plus minus 1 SD or more. So F represent the bias error, and shift is the sudden change in the control mean. This one is the example of shift error. So for random error, it is shown by this example. Yeah, from day 1 to 6. Okay, another way to detect error from the level Jennings chart is we use the Westcott rule. It is the rules that are used in conjunction with each other to provide a high level of error detection while reducing the incidence of false rejection. There is different combinations of rules depending on the number of controls being used and the total allowable error. The purpose is to detect high error detection and low false rejection. So this is the typical rule combination. This is the Westcott rule for 2 level of QC, example for chemistry test. And these are the rules for 3 levels of QC, example the immunoassay and hematology test. So let's go to each of the rule. First we go to the 1-3S. 1-3S meaning that 1 QC is outside of the plus minus 3 SD. Okay, 1 QC is outside plus minus 3 SD. Yeah, so in this case, this example, the QC is outside from the minus 3 SD. So this is, it may indicate shift, may indicate systematic error or increased randomness. So the action reject run, meaning that the QC is violated, and the sample we have the patient sample that we run together with it, we need to reject the result and we need to troubleshoot, yeah, whether it is random error or large systematic error. Okay, now we go to the 1-2S rule. 1-2S rule meaning that 1 QC have violated outside of plus minus 2 SD. In this case, the QC is outside plus minus 2 SD, outside plus 2 SD, but still within the 3 SD. So this is the warning rule. Action, you need to repeat the run. If the second run is okay, then you no need to reject the sample. But if it is always occur, then you need to monitor or need to troubleshoot what is the cause of it. And usually it have connection with the QC stability after the thawing process. Okay, this is for the 1 level of QC. Let's say if you use 2 level of QC, it also can happen if in 2 levels of QC, in one run, 1 level is outside of 1 SD. Now another rule, 2-2S or 2 of 3-2S. 2-2S mean 2 QC is outside plus minus exceeding plus minus 2 SD. In this example, 2 QC exceeding plus minus or plus 2 SD. Okay, so for 2 level of QC, it also can happen if in one run, yeah, both levels, which is level 1 and level 2, is exceeding the plus minus 2 SD. So it indicates systematic error potentially affecting a specific portion of method curve, and the action may require run rejection. Okay, for the rule of 2 of 3-2S, meaning that for the 3 levels of QC, 2 of it are violated. Okay. Okay, now another rule, R4S. R4S meaning that 2 consecutive control is exceeding 2 SD. If you calculate here, this is the first run and then the second run, so the distance between it is 4SD. If you calculate 1, 2, 3 and 4SD. And for two level of control, it may also happen if in one run the QC distance in one run is 4SD. If you see, the QC of level 1 is in the positive side, which is exceeding the 2SD, and then the level 2 is at the negative side, minus 2SD. So if we calculate the distance between this data, QC data, 1, 2, 3 and 4SD. So the rule is R4S. So it is indicate random error potentially affecting a specific portion of method curve. So the action may require run rejection and need to troubleshoot. Okay, for another rule, for another rule, it is 41S and 31S. 41S meaning that for consecutive controls exceeding 1 SD but still within 2 SD. For consecutive control exceeding 1 SD, however still within the 2 SD. So if you use the two level of controls, it this example also can happen, meaning that in 2 times of running, both of the levels are exceeding 1 SD but still within the 2 SD. So 1, 2, 3, 4. So 4 data QC on the same side of the section. So this indicates systematic error, may signal a change in analytical characteristic of the system, example control load or cal load, and critical significance of change considered before taking any action. The action may not require run rejection, may not require immediate action, and it may be indicated to perform maintenance or calibration. Therefore, we must do checking on all components of the test system. Please note that for the 3 levels of control, it use 31S rule. It can mean in one run all the QCs are on the same side and between 1 to 2 SD area, and or one level of QC show on the same side and between 1 to 2 SD area. Okay, now for 10x or 12x. For 10x, meaning that 10 consecutive control is on the same side of the section but not exceeding, but most of it not exceeding 1 SD, and it is near to the mean. Same goes with the 12x. So most control does not exceed 1 SD, and it indicates a systematic error and may signal a change in analytical characteristic of the system, example control load or cal load, calibrator load. Usually it is not a clinically significant bias, and it can happen if you use the 2 levels of QC and both of levels are on the same side of the section. Okay, I continue. The action may not require run rejection, may not require immediate action, and may be indicated to perform maintenance or calibration. Therefore, must do checking on all components of the test system. And please note that for 3 levels of control, it use the 12x rule. It can mean in 4 runs, all the QCs are on the same side and not exceeding 1 SD, or 12 QC data are on the same side and not exceeding 1 SD, regardless of any QC levels. However, these are the real scenario that when we work in the lab that we always met. You can read it by yourself. Yeah. Also the scenario that happened. So the scenario given is example why nowadays some laboratories use 6 sigma QC instead of only label Jennings and Westcott rule. This is to solve the QC with precise and accurate performance. However, the QC data are consistent on one side of the label Jennings graph, either on positive or negative side of the label Jennings graph. So, how to troubleshoot? So we can use the type of error as guidance. So for random error, it is change in standard deviation, it is random outlier or random direction, and it represent imprecision or maybe inaccuracy, and the magnitude is not predictable. So in label Jennings chart, it shows as random distribution, while in Westcott material it shows as 1 to S and R for S. While the systematic error change in mean of control values or remain constant or predictable magnitude, it represents inaccuracy or bias of the method. So the error that we in the systematic error for the LJ, it is bias, trend or shift, which I have been mentioned. And for Westcott rule, these are the rules that represent that show the systematic error. So these are the possible cause of the random error. So we can troubleshoot based off this possible cause. You can read it by yourself, okay? And these are the systematic error and the possible cause that can happen. Yeah. So the troubleshooting can be done covering this possible cause. Yeah. This is the cause that the possible that can cause the shift error. Also, this is the possible cause that can show as trend error. And however, this is not the definite cause, and other cause that then this may give error to test system. So you need to understand the test system. You need to read the test principle nature from the textbook or from the insert. You need to understand the system involved. You need to read the SOP and understanding it, insert and manual. And you need to, in real life, you need to hands on the analyzer, to hands on the test. So whenever the problem occur, you can guess what is the problem and how to troubleshoot. But usually you can use all this as a guidance. Maybe if you need to, guess what the error. So with that, I end my presentation. Thank you and good luck.